A stationary particle explodes into two particles of masses m1 and m2, which moves in opposite direction, which velocity v1 and v2. The ratio of their kinetic energies e1 by e2 is m2 by m1. A particle of mass m1 is moving with velocity v1 and another particle of mass m2 is moving with velocity v2. Both of them have the same momentum but their different kinetic energies are e1 and e2 respectively. If m1 is greater than m2, then e1 is less than e2. A vertical spring with force constant K is fixed on a table. A ball of mass m at a height of h above the free upper end of the spring falls vertically on the spring so that the spring is compressed by a distance d. The net work done in the process is mg h plus d minus half kd square. An engine pumps water continuously through a hose. Water leaves the hose with velocity v and m is the mass per unit length of the water jet. What is the rate at which kinetic energy is imparted to water? Half mv cube. A block of mass m is attached to the lower end of a vertical spring. The spring is hung from a ceiling and has a force constant value k. The mass is released from the rest with the spring initially unstretched. The maximum extension produced in the length of the spring will be 2 mg by k. When a block of mass m is suspended by a long wire of length L, the length of the wire becomes L plus I. The elastic potential energy stored in the extended wire is a half mgl. What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop root 5 gr? On a frictionless surface, a block of mass m moving at speed v collides elastically with another block of same mass m, which is initially mm, at rest. After collision, the first block moves at an angle theta to its initial direction and has a speed v by 3. The second block's speed after the collision 2 root 2 by 3 into v. Particle with total energy E is moving in a potential energy region Ux. Motion of the particle is restricted to the region when Ux is greater than or equal to E. A particle of mass m is driven by a machine that delivers a constant power k watts. If the particle starts from rest, the force on the particle at a time t is root mk by 2 into t inverse half. The potential energy of a particle in a force field is U is equal to A by R square minus B by R, where A and B are positive constant and R is the distance of a particle from the center of the field. For a stable equilibrium, the distance of the particle is 2A by B. Two spheres A and B of masses m1 and m2 respectively collide. A is at rest initially and B is moving with velocity v along axis. After collision, B has a velocity v by 2 in a direction perpendicular to original direction. The mass A moves after collision in the direction and theta is equal to tan inverse 1 half to the 1 to the x-axis. A car of mass m starts from the rest and accelerates so that the instantaneous power delivered to the car has a constant magnitude p0. The instantaneous velocity of this car is proportional to t half t to the power of half. A body projected vertically from the Earth reaches a height equal to Earth's radius before returning to the Earth. The power exerted by the gravitational force is greatest at the instant just before the body hits the Earth. The potential energy of a system increases if work is done upon the system by conservative force. A particle of mass m starting from rest undergoes uniform acceleration. If the speed acquired in time t is v, the power delivered to the particle is half into mv square by t.